Okay, so today we're starting on section 3, lesson 2 of the making of a scientist. I'm sorry I haven't had work for you. I'm trying to finagle some things so that way you're caught up with the rest of your classmates. And now you are, so it's great. So today, what we're going to do is we're going to begin reading a book called 13 Planets, the latest view of the solar system. And now I'm not actually giving you the book, but I did scan the pages and they will be available to you on your Google Classroom. We will define unknown words and phrases in the text, and we're going to discuss the author's point of view about how many planets there are in the solar system. So, our culminating writing task: how does the process of scientific inquiry lead to the development of advanced technology? Well, this book actually is a really good example of that because without these advances in technology, scientists would have never been able to discover as much as they have about the planets. So while we're reading today, I want you to focus on, does the author support the claim that Pluto is not a planet? So a claim is a debatable statement. 2 plus 2 equals 4. You can't argue against that. 2 plus 2 is 4. That's the only answer you're going to get. So that is not a claim. However, Pluto is not a planet is a claim because there are still people who say that Pluto is a planet, even though it has been moved to the Kuiper Belt or made part of the Kuiper Belt. It hasn't moved anywhere. So I want you to focus on, does the author support the claim that Pluto is not a planet? All right. All right, here we go. So this is the book 13 Planets, and it is a nonfiction book, which means there's going to be a very specific way that we read this book. And so the first thing we're going to do is we're going to look for any images. So on this page, oh, why my arrow key is not working. Anyway, on this page, we do have an image. It looks like the sun and our earth and moon. And after we find an image, we look for something called a caption, which is a little words right around the picture that tells us more about it. Well, there's no caption here, so we don't need to focus on that. So then we keep going. Well, this page doesn't have any images. So, next thing we're going to look at is our heading. And the heading says forward, which if you see a heading and it says forward, that means it's just a little bit of background information before you start reading your book. Now, you can see that our text is set up in columns, right? They're columns. That means you're not going to read straight across the page. That wouldn't make sense. What you're going to do is you're going to start in one column, you're going to work your way to the other side of it, and then you're going to drop down and go to another line, and you're going to keep going until you've read all of column 1. Then you're going to go to column 2, then column 3, then column 4. That's how columns work. So, once upon a time, long ago and far away, there were precisely 7 planets: Moon, Mercury, Venus, Sun, Mars, Jupiter, and Saturn, all apparently revolving around a solidly fixed Earth. And then, about 5 centuries ago, came Nicholas Copernicus, who invented the solar system. He said the sun was really in the middle, surrounded by 6 planets: Mercury, Venus, Earth with moon, Mars, Jupiter, and Saturn. It was truly the sun system, with Earth now a spinning planet. It was all very simple and elegant. 3 centuries after Copernicus, things were no longer so simple. In 1781, another big planet, Uranus, was found, and then a lot of small ones were given names like Ceres, Astraea, Flora, Hygiea, and Calliope. In 1846, still another big planet, Neptune, gained planetary status. By 1854, there were 41 planets, and astronomers cried, "Enough!" So they all decided there were 8 large planets, and the little guys weren't really planets, but minor planets. There we go. Today, astronomers know that the solar system is much more complex and interesting than anyone dreamed of in the 1850s. There are more than 130 natural satellites, and more are being discovered. One, Saturn's Titan, is bigger than the planet Mercury. If Titan and our moon had independent orbits, they would qualify as planets. Astronomers now have orbits for nearly 500,000 minor planets, half of which have been assigned numbers, and about 15,000 of which have been given names. Almost all of them are irregularly shaped rocks, but at least one, Ceres, is massive enough for its gravity to pull it into a sphere. So it is a dwarf planet. And there are comets, hordes of them, in the deep freeze beyond Neptune. Occasionally, some of these huge chunks of dirty ice get nudged into the inner parts of our solar system where they thaw out and sprout long, beautiful tails. So, shooting stars are comets. And a few of these ice balls are massive enough to pull themselves into spherical dwarf planets. Pluto is one of these, smaller than our moon. Makemake and Haumea are still smaller, while Aries is a little larger than Pluto. Oh, that's not what I meant to do. Aries is a little larger than Pluto. Three of these even have their own satellites. Undoubtedly, more of these icy dwarf planets await discovery. For now, there are 8 classical planets and 5 dwarf planets, making 13. All right, so the next page, we're again going to look for an image, and we have one. And you might think that these are captions, but this is a diagram. So these little words are called labels, and it's just labeling the planets in our solar system. So if we go to the next page, we have a continuation of this diagram, but look, we also have a caption. So we're going to read this first. It says, "This artwork shows the relative sizes of the 13 planets, but not the distance between them. Using the planet sizes shown here, the sun would be about 40 inches, 100 centimeters in diameter, and dwarf planet Aries would be some 7,750 yards, or 7,083 meters away. That's 580 large school buses lined up bumper to bumper, or 77 football fields." So now that we've read the caption, we go back and we look at the heading, and it says the latest view of the solar system, which means we're going to be reading about how scientists see our solar system today. So it says, our sun is a medium-sized light yellow star. Its gravity holds 13 planets, plus countless asteroids and icy comets that circle around it. The planets are divided into 3 groups based on size, how tightly packed together they are, which is density, and what they are made of, which is composition. In orbits close to our sun, we find small, dense, rocky worlds of Mercury, Venus, Earth, and Mars. They are called terrestrial planets. The Latin word terra means lands. Past Mars is the asteroid belt, an area filled with rocky leftovers from the time our solar system forms. Hiding out inside the asteroid belt is a new type of planet, a dwarf planet named Ceres. Located beyond the asteroid belt are the gas giants, Jupiter, Saturn, Uranus, and Neptune. They are monster worlds made of frozen gases surrounded by rings and numerous moons. Beyond the gas giants is the Kuiper Belt, an area filled with comets and other objects. The Kuiper Belt also contains 4 other dwarf planets: Pluto, Haumea, Makemake, and Aries. All right, last 2 pages. So again, we're going to look for an image, and we have an image, and we have a caption. So let's take a look. It says, wherever astronomers point their telescopes, they can see new solar systems forming. Some have thick dust rings shaped like donuts with baby planets hidden deep inside them. Other stars have thin dust rings with open spaces where new planets have already come together. Today, we have identified more than 1,000 new planets circling distant stars, as well as 47 new solar systems around distant stars. The number of newly discovered planets will increase to the thousands in the next few years. Maybe one of these planets will resemble our own Earth. And on the next page, we have another image, another diagram of our solar system, and another caption. It says, you can think of our solar system as a neighborhood in space. The rocky planets are like small city apartments nestled close to the center of town. The gas giants are big homes out in the suburbs, and the dwarf planets are like small camping tents located in parks on the edge of cities. Ceres are way out in the countryside. Pluto, Haumea, Makemake, and Eris. So, how our solar system formed? So, what is this going to be about? Well, exactly what it says, how our solar system formed. About 5 billion years ago, a huge star exploded into a supernova. This explosion sent shock waves rippling through space, creating a swirling cloud of gas and stardust. As the cloud spun faster and faster, it formed disks with glowing red bulges at their centers. One of those bulges began to slowly heat up and eventually became our sun. At the same time, not far from this bulge, bits of dust and rock containing carbon, silicon, and ice smashed together to form small objects called planetesimals. These soon merged into the terrestrial or rocky planets like Earth. Located close to the sun, these worlds were rich in metals like the ones we use to build bridges and cars. In the outer reaches of space, larger planets like Jupiter and Saturn collected ice, hydrogen, and methane gas to become gas giants. Beyond these frozen worlds, the dwarf planets formed out of ice and rock. And that is where we're going to stop reading. So, we have a quote here. It says, there are more than 130 natural satellites, and more are being discovered. One, Saturn's Titan, is bigger than the planet Mercury. If Titan and our moon had independent orbits, they would qualify as planets. So, we need to understand the meaning of the phrase natural satellites. Well, a satellite is a machine that orbits planets, sometimes taking pictures, sometimes sending signals, but they're not natural. They are man made. So if we put the word natural in front of it, then it must mean that it is something that is not man made, naturally occurring, that orbits planets. So then, what does it mean for something to have an independent orbit? One, Saturn's Titan is bigger than the planet Mercury. If Titan, which is a moon, and our moon had independent orbits, they would qualify as planets. So our moon and Titan, they revolve around planets. Our moon revolves around us, Titan revolves around Mercury, but they don't revolve around the sun. If we took Earth or Mercury away, made them invisible, then it wouldn't look like our moon or Titan would be orbiting the sun. So an independent orbit must mean that it is something that orbits the sun by itself. Because the only reason that Titan or our moon go around the sun is because planets are pulling them. Earth is pulling our moon. Mercury is pulling Titan. So an independent orbit means that something that goes around the sun by itself. So then what does this add to our understanding of the definition of planet? Well, a planet must be something that has an independent orbit. It must be something that goes around the sun by itself. So then let's take a look at this quote. It says, almost all of them are irregularly shaped rocks, but at least one Ceres is massive enough for its gravity to pull it into a sphere. So it is a dwarf planet. Well, what is a dwarf planet? Well, let's take a look. We said Ceres is a dwarf planet, and almost all of them are irregularly shaped rocks, but at least one Ceres is massive enough for its gravity to pull it into a sphere. Well, that means that Ceres isn't an irregularly shaped rock. It's a rock. But it has so much gravity that it pulls it into a sphere, which is like a ball, instead of just random rock shapes. So a dwarf planet is a rock out in space that has enough gravity to make it into a sphere. So then what does this add to our understanding of the definition of planet? Well, since not every rock, even if it makes it into a sphere, is not considered a planet, then it must have to do with size. Because if we're saying something is a dwarf planet, we're essentially saying that it is a small planet. Not a full planet, but a small one. So our definition of the word planet also has to take into consideration size. So this is the question that you're going to be answering on Google Classroom. And it says, according to 13 planets, how many planets are there? Well, I'm going to go ahead and give you some help with that. If you go all the way back up to the beginning, to this page where it says forward, and you look right here, you have got your text evidence for that. So I'm going to let you try this question out on your own without me walking you all the way through it. I want 3 sentences. I want you to restate and answer your question. According to 13 planets, there are, and then fill in the blank. I want you to cite your text evidence. In 13 planets, it says, and then go back to that page, find a sentence that supports your answer. This means explain your text evidence. I want 3 sentences. If you're not giving me 3 sentences, you're not getting all of your points. So I'm going to go ahead and let you get to work. Those pages from 13 planets will be attached to your Google Classroom so you can take a look at them on your own. And I will see you soon. I miss you, buddy.